Hey physics friends, and welcome to Unit 5 practice problems. There were 3 questions that I'm going to go through just to take you through exactly how I would do it. So you can see exactly what we're doing, what maybe you went wrong or got a little confused. Okay, a 1.4 kilogram block. It slides across a rough surface such that it slows down. So it's going to be accelerating this way at 1.25. I'm going to say that the positive direction is that way. So, and I'm maybe going to put a couple lines to show it moving to the left, but it's slowing down. What is the coefficient of kinetic friction between the block and the surface? So this coefficient of kinetic friction equals question mark. So here we are. Number 1, I'm going to put in all the forces that I've got. So I'm going to say that there's a downward force of gravity, and I take 1.4 and I multiply it by 9.8, and you get 13.7 newtons. There's a normal force. It's the same as gravity because it's a level surface. I'm not pulling up or pulling down. There is friction holding me back, and I don't quite know what that is because the only way I'm going to find the coefficient of friction is through this equation. So I don't know the coefficient of friction. I do know the normal force now, and that's 13.7. But I don't know the force of friction. If I could somehow figure that force of friction out, I would have this problem licked. But what I do know, and the thing that I'm not leveraging yet, is this, that the acceleration is 1.25. So I'm going to use Newton's second law. And I'm going to use the net force. And that's all of the forces combined. But this force cancels off this force, and the only force left is friction. The mass of this is 1.4, and the acceleration is going to be negative 1.25. So my force of friction, if you multiply 1.4 by negative 1.25, you get negative 1.75. So this force of friction, throw it down here. Why did I just change that to positive? Because the coefficient of friction can never be negative. So when I solve for my coefficient now, I get 1.75 divided by 13.7, and you get 0.13. Now I just made that positive because that's legal. Even though it's supposedly negative, my coefficient of friction isn't going to be a negative number. Alright, so number 24 says there's a shuffleboard disc that's accelerated to a speed. Now, maybe it takes a little bit of context. Like, if you've never played shuffleboard, it's this old school game where you take this disc and then you push it. And the idea is to push this disc and make it land towards the end as close as you can to the end, and then another person pushes one, kind of like bean bags. You knock each other off. But this disc, it's initially going 5.8 meters per second. The coefficient of friction is 0.31. How far does it go before it comes to rest? So it goes down here, it slows down and stops. I know that they say the court is 15.8. I don't know if it goes the full length of the court. I'm not going to assume off the front that it goes exactly all the way down and stops at the very end. I don't know. So I'm just going to leave that unknown for right now. So we want to know how far it goes. Well, that makes sense. How far does it go? It's probably not going to go, because then the answer, you'd be done right now, and the answer is 15.8. So I'm going to assume it's not 15.8. I think this is a number that we're never going to use. we want to know, how far does this thing go? So let's start with our forces. So we've got the force of gravity. And this is tricky because they don't tell you the mass of the disk. And super secret, if they don't tell you something and you need it, it probably doesn't matter. So make up a mass. I'm going to say my mass is equal to 1 kilogram. It probably doesn't matter, and let's see if we can figure out why it doesn't matter throughout this. So if this is 1 kilogram, then the force of gravity is going to be 9.8 newtons. There's a normal force acting up on this thing. It's on level ground, so that's going to be 9.8 as well. And then there's friction, slowing me down. And the force of friction, we can actually figure that out. It's the coefficient times the normal force. And the coefficient is 0.31, and the normal force is 9.8. So 0.31 times 9.8, and that equals 3.0. So we know our force of friction over here. 3.0 newtons. All right, how far does it go? I think I'm going to have to use one of the big three equations, right? I'm going to have to, like, if I know the initial velocity is equal to 5.8, it stops, right? It stops. We're looking for the displacement. I think what I'm going to do is I'm going to find the acceleration. I'm going to find the acceleration from F equals ma. And I'm going to use the net force, which is the sum of all the forces acting on my disk. So this force, gravity, cancels off this force, the normal. Those two are equal and opposite. So the only force left over is friction. My mass is 1.0 and my acceleration. Okay, I can see where this cancels itself off now, because I multiplied by 1 at the beginning, and now I'm going to divide by 1 over here to find my acceleration. And I get 3. I kind of want to be careful when I go from here. Because I said this is a positive number, I'm saying that this direction's positive. So that means that my friction should be negative and my acceleration is going to be negative. Acceleration -3. Now I can plug this all into that big equation that doesn't have time. Vf squared equals Vi squared plus 2AD. Final velocity squared, initial velocity squared plus 2 times my acceleration times my displacement. It ends up going 5.6 meters. So it doesn't go the full length, and that's what we thought from the beginning. I think this was a number they just gave you to throw you off the trail. The last question. Stacy has a mass of 45 kilograms, and she's on an incline of 45 degrees. So I can figure out gravity right now. It's 45 times 9.8, which turns out to be 441. If the coefficient of kinetic friction is 0.25, what is her acceleration? Okay, so the other force I've got is the normal force, and the other force acting on this is friction. So what we're going to do is we're going to look for diagonal vectors, and it turns out that normally the normal force and friction would be the diagonal vectors, but in this case we're going to rotate gravity, so we got to find the force perpendicular and the force parallel, with this being 45 degrees. So if I take 441 and I multiply by the sine of 45, I end up with 312. And because this is a 45, 45, 90 triangle, this is also 312. It's an isosceles triangle. So this, gravity, no longer applicable. So now, my normal force I know is 312, because it's the same as that. And now I can find my force of friction. Coefficient times the normal, which is 0.25 times 312. So 312 divided by 4, you end up with 78. Now you can figure out your acceleration from F equals ma. And remember, it's the net force. So it's the sum of all the forces acting on this. This cancels out with that. And then I'll make positive down the hill. So I've got a positive 312 and a negative 78. My mass is 45, and my acceleration is unknown. So 312 minus 78 divided by 45, you end up with an acceleration of 5.2 meters per second squared.